Well, good afternoon. Welcome to Comp 422, Comp 620, Information Privacy of Security. Uh, regardless of regardless of what the slide here says, this is not the Comp 7, it's the usual class. We're going to talk about reverse engineering this morning or this afternoon, and then we'll go back and do a review for the class. This is much on reverse engineering. Okay. Reverse engineering is used in a lot of fields. People take apart widgets and try to figure out how do they work. Yes, it's basically trying to determine how something works. You don't really know in the beginning. So you take a look at it, maybe open it up. Same thing with software. You try to figure out how it works. Say you just have the executable. You can take apart the executable and see what is it doing, how does it work, what interfaces does it have. It's interesting to note that long ago, and when the IBM PCs first came out, those of us who remember that age, IBM made the original PC. Apple made its computers, and then IBM made the PC. But almost as soon as IBM brought out theirs, all sorts of other companies started bringing out lookalikes. And they reverse engineered the BIOS, and that's how they made it work without IBM's licensing. If you have a compiler, then you write your source code, you run it through the compiler translates the source code to machine language. There are decompilers out there that do the reverse. They take the machine language and they convert it back to source code. The level of source code depends a lot on the language that we use, the information available. Sometimes it looks just like what it started with, and other times all they can get back is assembly language. There are a bunch of programs that will do that for you. Some of them are free, open source programs. If you're reverse engineering a program, a lot of times it really helps if the people who compiled it turned on the option to save the debugging information. What are the names of the variables and stuff like that? And of course, if you don't want to be reverse engineered, don't turn those options on. Why would you want to reverse engineer? Well, sometimes you want to check on interoperability. What interface does this use? What kind of system does this expect to connect to? You can look at that. Of course, people do it for to find out how the program works. Basically, they can steal the software. How is this working? Let me look at it and figure out how it's working. Also, sometimes you might want to look at old code. Say you have the source code for a program, excuse me, you have the executable for a program, but you don't have the source code. And you want to figure out, how can I change this? I want to update this old program that we've had for a long time and it works well, but I don't have the source code. Well, you can reverse engineer it sometimes and get the source code back. Yes, A&T has worked with a couple of the national labs, and they've told me they're very interested in students who understand reverse engineering, because they are in the process of trying to reverse engineer malware that they find. In other words, they detect malware, but they're interested to know, is this malware out to get the national lab, or is just out to get anybody who happens to land on it? Because they're much more interested in malware that was specifically coded to attack the national labs or the US government. So they want to know what was it doing. So students who can look at the malware, the executables, whatever form they have, take it apart and try to decide what was it doing. Simple one, well, is reverse engineering illegal? If you ever read the end user license agreements that you have with software, almost any software you get, one of the things you'll find in there is you can't reverse engineer this. Well, actually you can. So you can look at it. Now, what you can do with the information that you reverse engineered is limited. Copyright laws protect you from copying it. If you reverse engineer it and then create something that's a copy of what you reverse engineered, that might break a copyright law. If, on the other hand, you just want to see how it works, you can do that. There are laws that particularly state that, yes, in order to achieve interoperability, in other words, if you want to make sure that this program works with another program and you want to see how does it do that, you can reverse engineer to check that. other uses of reverse engineering may not be allowed. Particularly, they don't like you to figure out how copy protection works. I have an example about memory dump. One of the things you can do is you're running a program, you can stop it, look at the memory, and see what is going on. I have an example here. We've talked about this before. I'll just give you a quick, this is really go over this quickly. And just to let you know, memory analysis will not be on the exam. But here we have a simple little C program. It's got a couple of methods. The main program down here at the bottom starts it. Of course, the way things always start. Main calls method A. Method A has got two parameters, adds them together into GOAT. Calls method B, which prints stuff out and returns. If you look at the stack, of course, the stack has a bunch. It has local variables on it. Frame pointer points to the previous frame or information about it. And there's a return address, so the program, when it returns, it knows where to go back to. And then parameters. Here's an example of a memory dump. This is all in hexadecimal. This is in a Microsoft system that used the hexadecimal CC character as a stack canary. And you can see the stack canaries out there between stack entries. The EBT pointer, or the base pointer register, points to the activation, the current activation frame. So say the value is this. So it's pointing to that. We can look at this in some detail. Might note, by the way, that addresses are reversed in an Intel machine. The bytes are in reverse order. It's what they call a little endian machine. And so 00102390 is the address. It's this address down here. And so this frame pointer points to the previous frame pointer. Now here's a return address. It's 000 or 801460. 801460. So that's someplace in method A because it's greater than the beginning address of method A, but not up to the main address. So it's method A. And you'll see that this points back. So return address is method A. This is in method B, which returns to method A. If you remember the program method A calls method B. So method, when you look at this, this was in method B. It's called returning the method A. Method A returns the 801870, which should be somewhere in the main program. And you can see the parameters. This passes a parameter of 9. This is a parameters 2 and 7. If you remember the program, it adds them together, makes a local variable, adds them to 9, and so forth. Okay. Java language doesn't make executables for a particular machine. Instead, it makes class files, byte codes that can be executed on the Java virtual machine and therefore run on anybody's computer, regardless of its architecture. You can disassemble these byte codes with the Java. One of the programs that comes with Java. You can disassemble it and undo it. Look at how the program works. It works pretty well. And if you use the G option when you compile things, which in several compilers is default, saves information useful for debugging, particularly program names. Here's an example of a program. Okay, it's got 3 class variables, global constants. It's got a method A, method B, and a main program. It looks like the previous program, doesn't it? And it calls the main calls method A, adds them together. Well, here's the version of the program disassembled. I compiled that and then took the compiled version and disassembled this, uncompiled it using one of the available tools. And you'll know it's pretty darn, it's very close to the original. Well, the original, we had 1 line goes static and convert it to 2 lines. Doesn't do anything. It's interesting to look at method A. In the original method A, I had this variable goat, I add a cat and dog and pass as a parameter, and that value was returned. Well, in the disassembled version, there is no cow. There was a cow variable up here. There is no cow down here. Instead, when the compiler compiled that, it said, we don't need this cow. We'll just add the variables together, call it, and put the return here instead of calling it, returning it to cow, returning cow. This just, so yes, while the original program is like this, the compiler said, just make it into this and see what it's done, and so forth. So it looks very much like the original program. Same variable names because the compiler saved variable names in the class file, and the uncompiler pulled those out and used them. So you can see, you can get right back. So if you have a Java program, somebody could easily get it right back to what it looked like, almost what it looked like, maybe even better than what you had originally. Which tells you, you can do this, of course, with C, C++, Java, that if you have a program, people can look at source code. They can make source code over it. So if you think you have a secret in the executable, you know, keys or something that you're checking, you ask them to enter a password and you check it in the program to make sure it's what the program likes. Well, that's all in the source code of the program, and they can look at it. So there aren't many secrets. That is not, so just because you ask the user for a password, look in the, compare it to what you think it's supposed to be in the program. Don't let them in unless they enter the right one. They can get around that. In fact, I remember when I was an undergrad, there was a program that you couldn't run except at certain times of the day because they tried to make sure you didn't mess up the system's performance by running this in the middle of that day. So whoever wrote it decided to be kind and put the option in. Well, it was, I think it was actually a Thanksgiving vacation. I had a bunch of friends over. We thought we'd run this program. Oh, it won't let us. Oh, yes, we can. We went out, debugged it, found that code, that checked the time, pulled that out, ran it, and yep, we could run it anytime we wanted to. Obfuscation is a way of trying to get around that problem. Obfuscation is transforming the program so it does the same thing, it produces the same results, but it's difficult for humans to understand. Now, remember, a lot of systems is interpreted. If you're doing a Python, you got to look at the Python program, and even programs like Java that create a class file. When you undo the class file, it's pretty easy to see what they did. They'd like to mess them up so it's not at all easy to see what program does when you look at the uncompiled version. Remember, of course, that you have to give the users an executable. If they can look at the executable, they can see what the program does. So sometimes you might want to obfuscate it or rearrange the code so it does the same thing, but it's hard to understand. Okay, so what good is, well, definitely obfuscated code. I'll show you some examples in a minute. Definitely make it hard to read, but it's not important that humans read it. It's important that computers can execute it. Computers can still execute it, so they can still run it, so you can still. Obfuscation is that old security through obscurity. It doesn't really make it secure. People think it makes it secure, but it doesn't really. Now, I'd also point out that some people, when they obfuscate their program, it makes it smaller, because usually when you obfuscate, they take out all the blanks and the end of lines and the stuff like that, squishes it all together. And sometimes it's smaller. So if you're putting it in a file and shipping it over the network, it may be a smaller version of the program. Well, we got a clicker question here. Okay, let's try this poll. Well, fire that up. Oh, okay. Hopefully you can see the poll there online. Can the online people see the, oh, I guess you can, because you're answering. Yes. Okay, thank you. Okay. Well, about 20% said B, 50% said C, and 30% said D. Well, the answer is really C. You can still do this if you encrypt it with a public key. Now, I'm assuming you have like a public key certificate, because you're sending it off to the server using the server's public key. The server has the private key. So if you encrypt it with the public key, only the server can decrypt it. Therefore, you can use the public key. People can see the public key. So there's no real secret, it is public. So if you encrypt something with the public key, nobody else can see it. The server can decrypt it, and the key is not secret. With public key encryption, if you use the RSA algorithm, you can encrypt and decrypt in either direction. Otherwise, you could also encrypt it with the private key, and then it would be required the public key to decrypt it. But we're assuming that the public key is public. So if you encrypt it with the private key, everybody could decrypt it. It's not what you want. All right, so what is this? Yes, so the answer there is, all right. Oops. There we go. Obfuscation does several things. One of the things that there's a list of simple things it does. It usually does more than these. These are the ones you often see. It will change some of the loops to recursion. That, particularly for students, and I've taught enough programming classes, enough students to know that students just hate recursion. It's a really powerful tool, and it's worth understanding. But students hate recursion. So if you put a loop and make it recursion, they'll just go into fits. Change the variable names, replace if then else with conditional operators. So here is an example of an if then else. If cow is greater than dog, then set cat to 5. If dog is 5 times cow, then set cat to 3, and else set cat to 7. Like that. And they remove all the denting and white space. This method here becomes A question mark B colon C question mark D colon E. That's pretty weird. That is an inline conditional statement. Here's an example program. It's really simple. When I wrote this, I had animal names, like I always use animal names for any of you who've actually had me in beginning programming. I went back because that absolutely obfuscates it enough. I went back and put logical names in there. If you obfuscate this, it looks like this. It's much smaller. You can see it turns to this. It took out all the blank space and indenting. It changed the variable names. Now we have variable 1, variable 2, and they changed the if to an inline if, which is really weird. Also, you'll notice they have variable 1, arrow 2. What that means is shift variable 1 to the left by 2 bits. Well, that's because up here we're multiplying size by 4. And if you think about it in binary, if you shift a binary number 2 places to the left, that multiplies it by 4. 1 place multiplies by 2, 2 places by 4, 3 places by 8, so forth. So this does click it. And the if statement is backwards. This is less than or equal to 25. This is greater than 25. They reversed the order of the results. By the way, there's no return contains the conditional if. And they were kind of clever with the constant. They have a constant v equals 8, where the original program didn't had a 7 and 8. And so what they do is it was less than the return 8. Otherwise, they return the dash v2 means subtract 1 from 8, which becomes 7. So it is pretty weird looking program, but it does exactly the same thing as a much more understandable program does. And that's what obfuscation does. On the other hand, it gets the same results. And a computer program can easily look through this and see that it gets the same results. There are some disadvantages to obfuscation. It makes the program, obviously, while it makes the program difficult for humans, programs can still take it apart and figure out what's going on. Debugging is really, really hard for the obfuscated version of the program. If you write a program and you obfuscate it, and then it gets an error. Go, oh, what's wrong with it? how do you run the debugger on? Running the debugger and trying to figure out what's going on with a really small program. Also, they tend to remove all the lines. So if you look at the program, you'll say it's on line 1. Everything is on line 1. There isn't a line 2. It doesn't break things up into lines. It also adds another step in the build process when you're building it. You've got to do all those things and then obfuscate it. And of course, you need to use the tools, because if you manually obfuscate it, you're likely to introduce errors. Now, obfuscation makes the program difficult to read. If you have malware, that's an advantage. If you obfuscate malware, it's difficult to see, difficult to understand what it's doing. Also, if your program is obfuscated and it's been modified by some attacker to add malware to it, if it's obfuscated, it's very difficult to see what's going on and see if there's added something to it. Now, for the attacker, there are multiple ways you can obfuscate a program. I showed some examples, but there's lots of different techniques you can do, and you do them in different orders, and you get different results. And so if you do these different techniques to your malware, you end up with multiple different versions of your malware, which makes all the more difficult for antivirus stuff to detect. So that's reverse engineering. Any questions about reverse engineering? Well, hearing none, then I'm going to go on to the next topic, which is getting ready for the exam. So let's, okay, just a minute here. Okay, hopefully, yes, you can see that now. I kind of like the cartoon. We talked about information about keeping it private. So that's a privacy project. Okay. All right. Review. Here is our calendar coming up. We're getting near the end. The final exam is in 2 weeks. The end is near. We're talking about university and review. On Wednesday is the 3rd exam in this class. Next week, Monday, actually, I'm not sure it's going to all be data harvesting. I made that up at the beginning of the semester, and it's likely to be a selection of multiple topics that I'll put out there, things we haven't covered. And then on Wednesday of next week, we'll review for the final exam. Now, the exam on Wednesday, like before, same rules as we've seen before. The exam is going to be online. And so, of course, it's open book, open notes, open web, and open AI. Yes, you can take those questions and copy them into ChatGPT and see what the answers are. I've already done that for all the questions. It really makes writing an exam so much more difficult than it used to be just a couple of years ago, because I would take that question, I copy it in the ChatGPT, and it gives me a really nice answer. And I go, I can't give you that question. So I had to do sneaky things to make the questions AI proof, sort of. I think so. At least I didn't get good answers out of ChatGPT, which a hint you might guess. Okay, do not plagiarize. Okay, again, you can look at all sorts of sources. The thing you can't do is talk to your friend, talk to somebody, another living person about the exam. The only person you can contact is myself and the 2 TAs. If you have any question about the exam, contact me immediately. You can email me or text me or even call me. Wednesday morning, I will not be able to reply right away as I'm giving the Red Cross a bunch of platelets, and I'll be strapped down and unable to answer my phone. So if you do have a problem, it needs to be addressed immediately Wednesday morning. Contact one of the TAs, Mr. Ravel or Ms. He. Okay, questions? Answers have to be 5 sentences or less, no more than 75 words. Only nicked a few points off a couple people last exam. Most people got the word, put it in every question. Keep them short. I don't want people copying and pasting like they did first exam and giving me a book that they didn't write. So none of that. And again, the exam will be ready at 6 a.m. on Wednesday morning, and it runs until midnight at 6 a.m. on Wednesday. So that's the exam. Same thing as before. There'll be no lecture on Wednesday. If you have questions, then just me. In the past, I've had a lecture to ask if people had questions about the exam. That just didn't seem to be very fruitful. I think of people go, if in fact I detect from the questions, emails and phone calls and text messages that there's a difficult question, I will send everybody and we'll have a meeting. But unless that happens, and I hope it doesn't happen, I've had people reviewing my questions. TAs have reviewed it, and we threw out a couple that were a little vague. Hopefully, all of them are good. So there will be no lecture on Wednesday. The final exam, which is in 2 weeks, will be just the same rules, 6 a.m. to midnight. It's on Monday, December 11th, which is the normal scheduled day for the final exam. Now, the final exam schedule has a particular time. It has a 2-hour period. I'm giving you 18 hours. If you like, you can do it during the 2 hours. You can always do it any time during the 18 hours. It will not take you 18 hours to do the exam. It seems like, no, we did a quiz in the first one. It only took people about 2.5 hours on average. Some people were fast, some people were slower, of course. Now, does everybody have to take the final exam? No. After the third exam, I will put together your scores from all the programming assignments, all the assignments, all the previous exams, and come out with your grade. And I will email that to everyone like I did after the second exam. You'll get that score, and on that email, it will say whether you are or are not required to take the exam. Actually, the official wording is the exam optional for you. If it is optional, you do not have to take the final exam, and you will get the grade that you have at the end of the third exam. That will be, of course, in the email that I send to you. It will tell you what your grade is. If you're happy with that grade and the final is optional for you, then you're done. You don't have to take the final. If, on the other hand, the email says you are required to take the final, then you're required to take the final. You better do that on Monday, December 11th, or your grade will suffer significantly. So if you need to take it. Now, how do I decide who gets it? If it's statistically unlikely that the final exam will change your grade, then you're not required to take the final. So let's say you've got an average of 99 so far. And some students do. There are some students who've done very well in the class. They have almost perfect. You can go down to like, what is it, 87 and still have your A. You have to get a pretty miserable score on the final. And somebody who has 99 in the class isn't going to get that miserable score. So it's just unlikely that they're required to take the exam. So they don't want to take it. I don't want to grade it. So let's just not do it. And again, in previous years, the provost said, you always have to give a final. Can't let them out. So I gave finals, and there were students, again, who had the 99 average. He only had to get a 25 on the final exam to keep his A. There was a 4-page final. He answered the first page and turned it in. Didn't put anything on the next pages because his first page was good enough to get him all right, and he got his A. I'm glad he didn't make me grade the other 3 pages. So if you, but you will be told whether it's his. I also mentioned that if I say it's optional for you, you can always try for it. And if you get a really good grade, you may in fact improve your grade. If you get exam grade that's better than you've got before, which is usually what it's going to require. Usually you're going to have to get a grade better than you've had before on the exams in order to get a grade improvement. But if you want to try, go ahead. I might note that the evil Dr. Williams will drop your grade if you do miserably. On the other hand, if you are taking the exam There's going to be nothing tricky about the exam. It's going to be just like the other exams. I will very, very, very rarely does a student attempt and drop down. So I have to feel really mean those days when I do that. So, okay. Any questions about the upcoming schedule and the exams? So what are we going to cover in the exam? This is the topics that we have. Here are the chapters of the book. By the way, I made a mistake. Previous notes, this had 18.1. It's not 18.1. I went out, looked at 18.1. I go, where is this stuff on voting? And it's not there. It's an 18.2. So I apologize for that mistake. The textbook has very little on electronic voting anyway, so you can read 18.2, but it's not going to do you a lot of good. If you want to prepare for the exam, you should look at these slides and look at the videos if you want. All right, some topics that we've covered. Reconnaissance, looking out there, spying on the potential victim. Many things you can do, find out what kind of computers they have, look at their network mapping, all sorts of tools out there to explore your system and find out as much as you can about the victim before you attack them. And of course, in order to defend yourself, you have to be careful about what you make available, how you allow people to look at your system. There are network address translation boxes that translate addresses. So someone outside your internal network can't access any of the machines inside your internal network. And that's a big advantage. Intrusion detection systems. Intrusion detection system is software or sometimes a device with special software that monitors your network and looks for something that is unusual, something that particularly looks malicious, something that violates a policy. You can have network ones. Most ones I've seen were network oriented. They looked at the network traffic going back and forth, and they go, "Whoa, that's unusual. What is going on there?" And they alert an administrator that's saying something strange is happening. Or, this is what we see, and it looks bad. There are also host ones that operate just inside a computer, and they look for, oh, what are you doing accessing that file? What are you doing with this sort of stuff? That looks pretty suspicious. And again, alert somebody. Because an intrusion detection system goes out there and tries to check and see, does this look different? It's the kind of thing that machine learning works really well. This is one of the best uses of AI in cybersecurity, is having a machine learning system look at your system when it's running normally and understand, as you're training your machine learning system on the traffic that normally happens. And then it can be effective at using AI, machine learning, to detect something that's abnormal. Of course, you can still possibly get false positives where some legitimate user, some trustworthy employee is doing something different that day. And that's something that causes the network intrusion detection system to say, whoa, what is he doing? And of course, if the attacker sneaks something in that looks like it's the normal stuff that's going on, then the intrusion detection system might not notice it. Some of these systems that go out and look at other systems like Nmap, they'll often do it as quickly as they can. They'll launch as many messages out there as the network will support. Or you can tell it, well, no, wait so many seconds between each message so it doesn't look. If you launch out there and say, go to a machine and say, is port 1 active, is port 2 active, is port 3 active? Well, the intrusion detection system is going to go, that's really unusual. Regular activity doesn't do that. And they'll detect that. But if you go out there and you go, oh, is port 3 active? And a few seconds later, you go, oh, is port 1 active? Kind of randomize it, put some time between it. It might not look so bad, and it might not be detected. Okay, integer overflow. This was part of that dark web assignment, question 2. Let's take a look at this, because not everybody did really well on that part of the question. I got a lot of really interesting phishing email. and it was fun to score this one. Some people had a lot of imagination. Some people didn't have much imagination at all. And also, some people forgot to put the word fishing in the subject. And I think I told you to put the word fishing in the subject. And so you're going to lose a couple points for that. Because it got messed up, and I wasn't sure if this was real, if this was a student attack, what was going on. Okay, so this is a problem very simple to the one we had in the assignment. We've got cow is cow plus 5 is less than 12. Is that true if that's true? Well, what can we input that makes that happen? Well, if you input a really, really large, basically if you input the largest number that that integer will support, and this is a 32-bit integer. So the leftmost bit, the most significant bit, is the sign bit. If it's 0, it's positive. If it's 1, it's negative. So you want all the other bits to be 1, and that makes a really, really big positive number. When you add 5 to it, it adds it all together in binary, and the leftmost number bit flows into the sign bit. Now the sign bit becomes 1, and that becomes a negative number. So if you add this great big number to 5, you end up with this big negative number. Well, so if cow plus, so the compiler goes out there, takes cow, your big number, adds 5 to it, gets up this big negative number. Well, of course, the big negative number is less than 12, and that's going to be true. Best thing to do is never do any arithmetic with the input before you check to see if it's in limits. So you could just do cow less than 7. Of course, simple grade school algebra will tell you if you just subtract 5 on both sides, this is the same as that. But in fact, this will detect that, oh, this great big number, this will be false. And the answer to the assignment 2 is you have to go, how many bits you're supposed to go? Again, take your last 4 digits, your ID number, mod 31. In both Mac OS and Windows, there's a calculator. Calculator has a programmer mode. It has the mod function in it, usually represented as a %. You can figure out the mod. Anyway, you get the mod, get your number of bits, subtract 1 from that. Why 1? Because if this is a 32-bit number, we want the biggest number that fits in 31 bits. So subtract 1, raise it to 2 to that power, and that's your answer. Oh. Any questions about that in the homework? Yeah, we have a question. Yes, ma'am. Yes, so let's just say you did the assignment and you got a 10. Your last 4 digits, mod 31, gives you the number 10. So when less than is 9. So 2 to the 9 minus, minus 1. Oh, yes, this is supposed to be all that minus 1. I forgot to subtract the 1. Yes, because let's say it's 10 to 9. 2 to 9 is 512. No, the answer is 511. Yes. My mistake. Yes, you have to subtract 1 from that. And when we grade this, we'll be taking little points here, a few points off there. Okay. All right. Yes, so this is wrong. There's it's supposed to be this value minus 1. There's another minus 1. So once you compute 2 to the number of bits minus 1, then you subtract 1 from that. Okay. All right. A little bit going over stacks, because you talked about that, because that's a big part of buffer and stack overflow. We got a simple little program. You've seen this before. A lot of these slides, of course, you can tell I took from earlier lectures. Some are new. And again, if you have this program, it's got 2 parameters and a variable. It's going to push the values of the parameters on the stack, pushes the return address on the stack. Now you're in the method. It puts the frame pointer. This points to the previous frame. That if this is the frame you're looking at here, it's just the information for that method on the stack. And one frame points to the previous one. And this allows your programs to do stack tracebacks whenever you program. Particularly, I noticed in Java, whenever you get a Java error, you have this long list of this method called this method called this method called this method. How does it know that? By these tracebacks. Same thing happens in C++. Okay. And then there's the local variable. Now, you notice on Intel and several other processors, the stack goes down as you push things on the stack, unlike what you might have learned in data structures where you push something that's on the top, In this case, it's on the bottom. It doesn't matter. It's just memory. It puts it in the lower. Well, the interesting thing here is when you get to the bottom of a variable, this is cows 0, 1, 2, and 3, but as you go on, it puts it over the next one. So cow, if you add A, B, C, D, E, F, G, H, et cetera, then this goes to the cow. The rest of it goes into the frame pointer. The rest of it goes to the return address. If you are clever about this, and I showed you an example earlier that you can actually load information in the return address and cause the program to return to someplace else and do something nefarious. Now, one of the ways to help this is to put a stack canary. Stack canaries go between the variables. And I think you saw on the example about reverse engineering, there were all these hexadecimal CC characters. Microsoft Visual Studio uses the CC character as a stack canary. And so that puts there. So if you go past, particularly if you accidentally go past this, and then you'll change the stack canary. The program checks the stack canary usually before the method returns, says, oh my goodness, something's wrong, and we'll stop your program and say, oh, it's all messed up. Here's an example of a buffer overflow. Okay, we've got a very short buffer, only 4 characters. And if you remember in the C language, it always terminates a string with a 0 character, a binary 0 value, the terminator character. And so you can put 3 characters in there, not 4, 3 characters. And then when you're reading in characters at a time until you get the end of the file, let's just assume that the admin variable follows the string variable in memory. If you do this in Microsoft Visual Studio, this is in fact the case. If you do this in on a Mac OS system, I could never get that to occur. You'd have had this program as an assignment if I could get it to work on Macs. As I mentioned, it's been a challenge making the dark web assignment. People noticed we went a couple of weeks without any assignments. Every time I come up with a good idea, either ChatGPT could answer it better than most students, or I couldn't get it to work on both Windows and Apple machines. It just didn't work on both. We tried. And I thank those students that helped me try on Mac OS systems. Okay, but let's look at this program here. We've got 4. If we enter A, B, C, D, E, then A, B, C, D will end up in str, and then because the E will go into the following memory, which we assume would be the admin variable. So it says admin. Now, if there are stack canaries, you might have to put more than ABCD. After ABCDE, you might have to put some stack canary values, so whatever it looks like in a stack canary, if you happen to know that, and then followed by the E. So you can do that. And that way, even though the system has a stack canary, you'll have just overwritten it with the same thing and won't ever notice. The stack canaries will be overwritten, but they won't be changed. So you'll get away with it. Stack Overflow is a particularly dangerous problem because users can load their software onto your system, and then it will do anything they want. So how do you fix it? Well, of course, better software engineering. Write the program so it doesn't do it. This is a poorly written program because it doesn't check for the possibility of going past 3 characters. There should be a for loop or a check, while there's not end of file and I is less than 3. But if you did that, well, avoid dangerous functions. We talked about it in previous lectures. There's a bunch of functions, particularly in the C language, that because we wrote C a long time ago, and C has things like concatenate this string and the end of that string, and it never checks to see the size of the buffer where it's going. Just put it there. Language choice. Certain languages like Java, some of the Microsoft .NET languages will check for this. It won't allow that. Python, I don't believe, allows you to do an array overflow. And there are compiler tools. Microsoft Visual Studio can put those in. There are analysis tools. There are tools that will look at your program and say, oh, this doesn't look good. Execution prevention, that's a hardware feature. You can specify that certain parts of the memory cannot contain instructions to be executed, in particular the stack. So if your program is a buffer overflow, puts a program language on the stack, then tries to jump into the stack, the hardware will go, no, you cannot execute a program off the stack. It has to be only in the program segment, and you'll stop your program. And then randomizing the stack location so that whenever the program runs, the stack starts at a different address. And that makes it much more difficult for you to figure out where the programs are. Although there was something I read that said, well, when they randomize the stack location, they only randomize it, with using 16 bits. So it's any one of 65,000 different addresses, and you can guess those in a couple of minutes with the program, which is true. Okay, forensics. Talked about forensics. There were 5 rules of forensic evidence. Let's just quickly go over this. Admissible. Okay, the whole purpose of a lot of the forensics is to gather information so that you can present a case in court that somebody has violated the law, that you've gathered information from the computer to be able to prosecute some person for doing whatever they did. So in order to gather the evidence, it has to be admissible. You have to follow all the rules, in particular, the rules of keeping the evidence clean. You have to make sure that you don't taint the evidence in any way. Authentic. The evidence has to relate to the crime, to the information that you produced. Complete. When you're working on this, a lot of times you said, yeah, I want to prove that Fred did it. I know Fred did it. I'm just going to prove that Fred did it. Well, no, you got to say, I want to find out who did it, which might be Fred, but it might not be. Don't just say, I'm going to prove that this. Got to look at the big thing. Who actually, you're looking for who did this. It might be Fred, but until you can prove that, you got to look at all the evidence. Reliable. You want to make sure you do everything in a process that doesn't taint the evidence, that there's no question about whether. The big thing they talk about is, like in computers, copy the disk drive. First thing you want to do is copy that disk drive in a manner that uses a read-only copy. There are boxes. I used to have one that you could take the disk drive out of the computer, plug it into this thing, plug in a brand new drive, and it will copy every bit off the old drive onto the new drive. And then you can look at the new drive without having never changed the old drive. The device has no ability to change the drive. So keep that. And that way, the data was not tainted. And of course, the end, it has to be believable by a jury or a judge. Remember, they're probably not computer scientists. You're going to have to put it together in some way that nobody will go, oh, well, you just think it's probably this guy, but you haven't proved that it's this guy. No, if you're sure this guy, you have to put the evidence together in a way that the jury and the judge will understand that, yes, the information you have is correct. Yes, we mentioned this we talked about computer forensics. There's a process you have to go through, chain of evidence. We talked about the chain of evidence so that the evidence is always protected. Don't allow it to be corrupted. One of the things about the evidence is the defense needs to be able to look at the evidence and do their own analysis so that they can be sure that what you're getting is correct. So if you come up with a result, they have to be able to go out and see that that result is in fact correct. So identification, what are you going to do? Keep the data, collect the information off that, examine it. What do we have here? What data do we have? Once you have data, analyze it and try to make some sense out of it. What does it mean? And then put it into a presentation so that people can understand it and finally make a decision on what is the outcome. Not every forensic activity is for courts. Sometimes it's an internal company investigation. Companies think somebody's doing something that before they can fire them, they need to have evidence, and they might call you in as the computer guy and say, we're suspicious of this person. Check and see if she's really doing something nasty, and you might check that out and see if she is, or if you don't have any data that she isn't doing anything nasty. And also you do forensics, sometimes have nothing to do with inappropriate activity, but something's happened. Your system's crashed. What is going on? What happened? What caused this? And for instance, to go back and look at all the information you have and try to find out, why is the system down? Why did this program crash? What is going on? So you might have to look at all that. We talked about privacy. And I did mention that privacy varies from person to person, from culture to culture. I also noticed it varies a lot by age, that what people consider private. But we did a survey in class, and there were certain things that everybody considered private. Not everybody was. A whole lot of people were unhappy with the government watching your every move. Of course, the government's probably not watching your every move, but certain large corporations might be. So today, my wife got an email for our neighbor. Why did she get an email that was directed to the neighbor? It said, "Dear Bill," who was the guy who lives next door. Why did she get an email for him? Unless somebody had a system that looked at street addresses and mapped it back to known email addresses and made a mistake. He's just next door. But that was weird. That was a combination of information from multiple sources with an error in it. Yeah, so but privacy is trying to keep the information that people want to keep. There is information that people want to keep to themselves. And you should be able to do that. So we try to make systems that maintain individuals' privacy. And there are some laws out there for maintaining privacy, more so in the European Union. Oh, and we have another question. So let's do this poll. Okay. Okay, how are we doing here? Anybody else want to answer out there, out in the ether? Coming to the end of the semester. Attendance isn't very good. Participation isn't very good. Okay. All right, people clicked A and B. Nobody clicked C. That's good. C is definitely wrong. At least one person clicked. I was thinking B. B is the answer. If you put in data and you put in values, and then you know what the stack canaries are, you know how big they are. Sometimes they're always a fixed length. Then you put in the data, put in stack canary values for as long as you know the stack canary is. Then you've overwritten the stack canary, but you haven't changed it. So when the system goes to check if the stack canary is changed, it will not be changed. It will not detect your sneakiness. So you have to. So if there's a stack canary between variables, but you input a value that contains that stack canary, the system won't detect it. But actually, stack canaries are for detecting malicious activity, but also for detecting mistakes. Must be more than one student programmer who has written a program that overruns an array and might get an error or messes up the data. And a stack canary will tell you you're doing that. Okay. Oh, you see that? Okay, stop sharing. Let's get rid of this. All right, moving on. All right, open source intelligence. That's looking at available information out there, Google and Bing and whatever you have, all sorts of information. I mentioned it, there's a whole slide on it. But yes, here, social media, news reports, corporate records, publicly traded companies have to make all sorts of financial statements and other information available about the company. It's a requirement, and you can get the public available. You can get those. You can find out a lot about what they're doing. Where are they hiding their money? Is it in the Bahamas? Is it, in the Cayman Islands? You can find out where they put it. And you can do, of course, if you're doing this on a regular basis because you are out there sneaking around looking for people, you can make tools that do it for you. Whoa, whoa. I don't know if you saw that, but does everything look okay online?
Yes.
All right. Oh, okay. I'm sorry, it just got really weird on my side. But we'll continue on. Sorry for that. Okay, so that's open source intelligence, which again is part of the reconnaissance concept we talked about at the beginning of this, going out and looking at somebody to find out what they do and where they might be vulnerable. The dark web. I think you've all learned about the dark. Did anybody look any place interesting in the dark web? I know I was kind of frightened to click on anything. I was just I'm going to go to this CryptDB website and look what I have to and go away. But if you went out there and looked at the wiki, yes, just like you hear in the news, they're selling drugs, sex, rock and roll. Well, actually, I didn't see any rock and roll, but yeah, guns, drugs, all sorts of things was for sale on the dark web. By the way, the surface web, of course, is what everybody can see. The deep web are things other parts of the web where you aren't permitted access. Blackboard is Blackboard is an example of the deep web. You can get the Blackboard if you log in, but normal person off the street who's not an A&T student cannot access Blackboard because they don't have an account. So that's deep web stuff, but not dark web. Dark web is part of the dark web we'll talk about. That uses the onion routing. They have the .onion extension at the end instead of .com or whatever. You need to use the Tor router, the onion router, Tor router, because it encrypts things and sends it from multiple Tor routers from one site to another. This hides where it comes from, where it's going. The onion routing, your message does not go directly from your browser to the server like it will if you use Bing or Chrome or Edge or Safari or whatever it is you're using. That says, now, admittedly, in the networks, things bounce around from network to from server to server at a very, very low level that you never know about, but they're just bits coming in, bits going out. They don't even look at anything. Here, on the onion routing, it's happening at a high level. Message comes in. It's every Tor router has its own public key. Things are encrypted for it. Once it receives it, it decrypts the message with its private key, and then gets the information about where do I send this next, sends it to the next router, encrypted with that router's public key. Yeah, so kind of an example here. When you do this, when you start off, the Tor router looks at it. There's a table of all the routers out there in the world, and there's thousands of them. And it says they're supported by volunteers, and there's thousands of these out there. It randomly picks some and then routes your message through them and encrypts things. It encrypts things the last one and the first one in reverse order. So when it sends it to the first one doesn't know. All it knows is getting this packet, and it's encrypted for the first router. The first router decrypts it, comes up with the packages, tells it where it's supposed to go, and sends it off to the next one. And it can't make any sense of it because it's all encrypted with keys that it does not have, and it keeps going farther and farther until finally the last Tor router, before it gets to the website, decrypts it, and now says, oh, it goes to this website. It's now in clear, and it sends it off to that website. So if you wanted to buy drugs or something, now it goes to that website and says, oh, here's what's available. And then it's kept a identifier in all the routers, so you can go back and back it up. Okay. Denial of service. Denial of service is basically crashing the system. Remember CIA, confidentiality, integrity, availability. Big three things you want to accomplish with your, basically with cybersecurity. And availability is what we're talking about with denial of service. If somebody trusts, well, they can't break it in, but at least they can make your system unavailable to everybody else. And there are several ways to do that. Basically, it's crashing the system to keep others from using it. There are all sorts of ways of doing that. The example we've always used is the fork loop. Fork is a function in multiple languages that creates a new process, a new thread. It creates another copy of the program. And so you can just go fork, 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 and it makes multiple copies of the program, each one of which makes multiple copies. There's an exponential explosion of this thing. And suddenly the only thing in your computer is many, many copies of this program. Basically, you consume whatever resources you have, the CPU, network bandwidth, file space, any of those work. You have a program that goes out there and consumes them all. You also have Stack Overflow. In this case, Stack Overflow is not the kind of hazard. Stack Overflow is, think about a runaway recursion where it's using more and more of the stack. You have a program which calls a program, which calls a program, which calls a program, and each time you're doing that, puts more data on the stack. Eventually, Stack Overflow, mostly with recursion. If you have a recursive program that doesn't have an endpoint, then it just keeps calling itself until it runs out of space and memory. That's also a denial of service attack. You can change configuration. Sometimes if somebody makes an attack, you go out there and change like routing tables. Imagine a domain name server. You're changing how do you get from here to there. If you redirect packets, they will not get to the final destination and things will not work. And of course, then there's always the physical system. Just go out there and disable their power. The batteries may not, if it's really important site, they probably have battery backup, but the battery backup only works for so long. Or, of course, a lot of the big systems, battery backup for a few minutes, time enough for their diesel generators to fire up, and then they run on the diesel generators. And if they start running out of diesel fuel, they'll go out and get more. But that's always. But if you break those, so that one of the popular ways of doing a denial of service is the SYN attack, because if you want to create a connection with TCP, of the TCP IP network, TCP is a connection-oriented. Before you send any data, you have to inform the other site, I want to start talking with you, I want to form a connection, and send it what's called a SYN message to the server. The server sends an SYN acknowledgement back to you. Along with this, by the way, there's other information, sequence numbers you're going to use. The sequence numbers does not start at 1. They start at a random number. That makes it much harder to break into. Anyway, they start at a random number for very good reasons, and they give you what random number that's going to be, and then you acknowledge that you've got it. Okay, 3 messages. Then you start saying, well, an attacker might send lots of SYN messages to the server. The server then sends SYN acknowledges back to the attacker. The attacker doesn't acknowledge it, doesn't send back. So the server is waiting, where's all those? And it waits, they eventually time out, but until they time out, it's got all these half-opened connections, consuming port numbers, and slows the system down. Makes it possible for somebody else, a good person, to want to connect to the server. They send a message, there's no space, it can't do that. By not acknowledging, so several ways. Again, port numbers are only a 16-bit number, or 2 to the 16 is 64K, so there's only 64K possible connections, which, running at computer speed, you then consume those pretty quickly. And since often the timeout is a matter of seconds, and it takes a while. And of course, if you just continue doing this, you can make it stop everything pretty quickly. And one of the ways to make sure the system doesn't respond is that you fake the return address. You point to non-existent computers, or you point to a computer that's not going to respond. Most computers, if they get a SYN act for a computer that they never tried to connect to, they will simply ignore it. I don't want to be part of that. So that's how it works. Okay, hey, yet another question for you out there. Let's poll this one. Whoop. I got it. We're having some difficulties here. That is not what I want. Okay. There. That was much harder than it should have been. Okay, we've got it. Agreement in class. But oh, somebody else woke up and responded online. Oh, okay. Well, oh, more. There's more. Well, everybody's going to the same answer. B is the very popular one. The Tor browser uses onion routing. Safari, Edge, Chrome do not use onion routing. That's why they won't work when you try to get to the dark web on them. Oh, yes, there's the results. You can see almost everybody chose B. Let's get out of here. Okay, so that's that one. Election security, basic rule, voting systems should not be networked. You need to always make sure to keep multiple copies of the results, no matter what kind of system you use. Paper ballots tend to be kind of safe. People seem to like paper ballots. As an election judge, when I hand that person a paper ballot, we also give them the official ballpoint pen for the election, and we tell them that ballpoint pen has been carefully checked and has not been attacked by any foreign powers. So you just write on the ballpoint pen, fill it in. Now, put it in a machine. Of course, there's a machine that counts the ballots. You put it in a machine, and it counts the ballots. So if somebody was to attack that machine, that would be the way to do it. I might point out that here in Guilford County, that once you end the ballot at 7:30 on election day, you close down the polls, get the information, send it, by electronically, a couple paper copies off to the Board of Elections, and then you take all the ballots back to the Board of Elections. And so they can do an audit. They select random precincts, and there are lots of precincts in the county. I don't remember how many. And they'll say this precinct, and they'll look at what you reported for the ballot, and then they'll run those ballots through a machine to count them all, and they'll see if they got the same answer that you reported. If they don't, then they'll know something weird is happening. So that's a way of detecting that people have not been following the rules. Although there's also people involved too. I can tell you that we have myself and several other citizens who are working the problem. When we do this, you have to be in the presence of 3 people. You open the machine, you get the ballots out, you stuff them in the box, you close the box, you get a seal. People sign, 3 people sign the seals to say this is official. You go down. So a lot of people are watching the system. Yes, I worked on the elections back when people were complaining, oh, they stole it. Well, they didn't steal from my precinct, I'll tell you. I know my precinct followed the rules. Okay. And I always like to say, we're going to do a recount. If you have an electronic ballots, what is a recount? And I got to tell you, this is personal opinion here. Some people think that they ought to do just paper ballots and have them hand counted. That they imagine having a bunch of little old ladies, and I say little old ladies because a lot of the election workers that I've seen were little old ladies, and I thank the little old ladies for working the election. But yeah, there are 373,000 registered voters in Guilford County. When you look at an individual ballot, there's about 30 different races on it. Well, okay, 30 times there's over 11 million races. These little old ladies are going to have to work overtime to count 11 million races. That's just not, and you think they're going to do that without making a mistake? That ain't going to happen. No, we're going to have to rely on some machine at some point to do this. So we need machines. The system is too big to do manual. End of my opinions. So we have to rely on that. We have to make sure that we keep the machines that we use safe. Okay, malware. They have also animals involved, all sorts of things. There are Trojan horses. Trojan horse, again, is software that you use because it does something you want done, but while it's doing what you want in the background, sometimes with a separate thread, it's doing something that you don't want done. I might note that getting around to Christmas time, there's these greeting card programs. You don't see them too much because a lot of systems are very aware of these, but you used to get these executables sent in the email, and you'd click on the executable and open up, and it would show Christmas tree with things blinking. And meanwhile, it's doing something else in the background. They're still there, but they're more sophisticated now. Computer viruses are very much like a Trojan horse, but they also propagate themselves. They will attach the code of the virus to another executable that they can find, that they can write to. So they copy the virus portion from this program into another program. I might point out that digital signatures, if you have a digital signature attached to a executable, that if you change it, remember digital signature, if you change the code, then the hash won't work and it won't compare to what's there. So it won't, the digital signature will detect whether you've changed the executable. Of course, the virus, here's the original program. This is not the virus one. This is one in a directory, same directories where the virus is executing something that the virus can find, finds an executable in a writable directory. And so it copies the virus code to the end of the original executable, changes the start location. So now it starts off into the virus and then returns when the virus is off. And the virus will start a second thread so it can execute in the background while the program is doing whatever it's supposed to do in the front, in the foreground. Well, they do. A lot of your programs have digital signatures on them. Yes, both Mac OS and Microsoft Windows use digital signatures. Now, not every program has a digital signature, but if they put a digital signature on them, then it'll check it. And if it's been changed, it will not run it. Excuse me? A recount for like election? Oh, yes, the question was, what's the purpose of a recount in election? Sometimes people think that, how could they possibly have gotten an account where I lose? And particularly if it's a very close, if you have 20,000 people voting and the election goes out 9,998 to 10,002, you know, it's only 2 or 4 difference. Somebody will say, well, did we do that correctly? Maybe we ought to check and make sure that's correct. And so they will do a recount and count again. Now, it was all done by computer. Press the button, and in a couple milliseconds, you've got the same answer. But if there were paper ballots or things, humans involved, they might go out and recount all the ballots. I might note that if a candidate requests a recount, then particularly if the difference is if the difference between the 2 candidates is very, very close, then they can have a recount. If the difference is wider than whatever that limit is, but a candidate can request a recount, they have to pay for it because they're going to have to bring a bunch of people in, volunteers like me, they'll come in and work the polls and count this stuff. It's annoying. And that's happened. Last election, yeah, they requested recounts in several places, and it actually didn't help them. They found out, oh, it's even a greater difference than what they thought. Computer worms are out there. They go out and attack, and they're sort of, they don't attach themselves to other programs. Instead, they send themselves and copy themselves to other places. Often on the network, they'll send themselves to other computers. Rabbits are those programs that do denial of service. They just waste computer time. This is the classical one, but you can do many different types that consume files. You know, if you're copying files, if you have one, it goes out there, oh, it's going to waste space. Start copying files from other directories into a directory. So of course the file names all look good because they came from other places. They even have dates on them that are a mixture of things, and copy them all over the place. And now you fill up the disk, but yes. You can't go, you have to go out, somebody has to go out there, start deleting things. Botnets. A botnet is what occurs when programs are compromised by some piece of software. And then once the user has access to your computer through that compromise, backdoor, then they'll install some sort of software in there so they can then control that machine. Typical thing is they will try to infect a couple thousand computers, and then at the appropriate time, all those botnets will go out and attack some intended victim. And that way, many, many computers who the owners of which have no idea what's going on, their computer is part of a bunch of computers that are attacking some victim. And typically, of course, the malware wants to be secret. A lot of people say, oh, my computer is running slow. It must have some malware, it must have a virus on it. Most real viruses don't want to be found. They do not want to make your computer run slow. No, they want to have no impact at all, because you know, a real parasite doesn't kill its host. A real parasite keeps that host alive. Phishing. You had to send me a phishing, and again, I got a lot of really nice phishing emails. It's a big attack these days. They're phishing your pictures going up and up because humans just aren't real reliable. Those computers we can handle, but oh, it's time to go. Anyway, you've seen that. I will note this, the old found thumb drive. Yeah, watch out for that. In fact, there's a recent report just came out. I just found out about it today, that there's a Russian hacking group going out targeting Ukraine. Of course, they don't like Ukraine, but it turns out their attacks are spread out across other countries. They're trying to get information. And it is an advanced persistent threat. Remember, that's a threat usually put out by, again, a state or state actors. They usually put it in their computer like botnet. It doesn't do much. It waits to do something else later. Okay, here's the schedule. Got an exam on Wednesday. Don't miss it. The exam is in 2 days from now. Yes, ma'am. How many questions? At this time, it looks about 8. There'll be short answer questions, and keep the words short in mind. No more than 5 sentences, 75 words. And we go out and count. Well, actually, several tools will count for us, but yeah, if it looks like a long answer, we copy and paste it in and go, aha, 77 words. Well, 77 we usually let go. But we are taking points off for 90 words. And for 150 words, yeah, you're going to lose a bunch of points on that question. So follow the rules. That's a really easy rule to follow. That's because on first exam, people will get going out to ChatGPT, copying big pages, going from page, multiple pages of answer, copying in the answer, and we don't want to read it. We know you didn't write it, and so now at least if it's 5 sentences, you gotta. If you go out to ChatGPT and get something, you have to at least reduce it. By the way, I run all my questions through ChatGPT, and I know what the answers are. Remember, the exam starts at 6 a.m. and goes to midnight. If between 8 and 11 in the morning you find a problem, contact Mr. Raval or Ms. He and tell them about it. I will be unavailable, but I'm sure it will be okay. No lecture on Wednesday, next Wednesday, 2 days, because you're doing the exam. Contact me if you have any problem. The final exam, we'll talk about that. Okay, that's it. Good luck on the exam. If you have any questions, contact me, email me, text me, and we'll answer as quickly as we can. Good luck. Yeah, I'm sure you'll do well. And try not to make it too long or too hard.